estimating and checking results. When answering questions in maths, you will occasionally have to show how to check your answer. And even if you don't need to do it to earn marks in an exam, it is an important skill so you can be confident that your answer is appropriate. In this nugget, we'll focus on 4 ways of doing this. Firstly, by using inverse operations. Also, by checking the size of your answer by estimation. Does your answer make sense? Are you expecting the number to get bigger or smaller? Or is the context correct? And we can also check answers by asking, is the final digit correct? Imagine you have this question in a test. You're told that 6 packs of drink cost £3.78 and asked how much one would cost. This question requires division, and your working may look like this. And this gives an answer of 63 pence. You could then get asked to check your answer. You can do this by using an inverse operation. To answer the question, you used division, and the opposite or inverse of division is multiplication. So we need to perform a multiplication to get back to the original value in the question. If 1 drink costs 63 pence, what will 6 cost? This calculation should give us £3.78 if our answer is correct. So let's complete this calculation. And we get 378, which is £3.78. So we can be confident that we are correct and have clearly checked the answer. Next, let's look at checking the size of your answer. This question tells us that there are 9 screens in the cinema, each with 22 rows and 48 seats in each row. We need to work out how many seats are in the cinema altogether. There are 3 possible answers available to us, and they're all of different sizes. Without doing the exact calculation, we can work out the approximate answer by estimating. The exact answer could be found from calculating 9 times 22 times 48, but we just want to check the size of the answer. So let's round all of our values to the nearest 10 to make a much simpler calculation. Doing this calculation using a mental strategy, we first do 1 times 2 times 5, which gives us 10. And there are 3 zeros remaining in the question, so let's add these on. This means our answer is approximately 10,000. And out of all 3 answers, the first one is closest to 10,000 at 9,504. So this must be our correct answer. Next, we're going to check if the answers make sense. And there are various ways we can do this. Are you expecting your answer to get bigger or smaller? Or does the answer make sense in context? Is it logical? In this question, we are told that Austin has a salary of £25,000 and that he gets a pay rise of 4.5%. What is his new salary? Let's take a look at an answer that somebody has given. They get a final answer of £1,125. But if we compare his old and new salaries, we can see that the new one is lower. Austin had a pay rise, so this new value should be higher. So there's been an error. Can you spot where it's been made? They have found 4.5% correctly, but they need to add it on to the old salary to get a new salary of £26,125, which does make sense. It is higher than his previous salary. Let's look at some context. In this question, we're told that Carly is walking 2,000 metres to a friend's house and it takes her 25 minutes. We are asked to find her walking speed. Again, let's look at somebody's answer to this question. Through their working, they get the answer of 50,000 metres per minute. Does it make sense that a walking speed is 50,000 metres per minute? That's 50 kilometres every minute. So in this case, taking the time to think about whether the answer makes sense in the context of the question tells us that it is wrong. The mistake is in the formula. Speed is distance divided by time, which gives an answer of 80 metres per minute, which seems much more likely and possible. Our last way to check answers, or quickly see whether an answer could be correct, in multiplication and addition questions is by looking at the final digits. In this question, we have a multiplication that would take a while to do without a calculator, but we can quickly see which answer is correct, even though all the ones available are similar and therefore look feasible. And we can do this by looking at the final digits. If we take the last digit of each of the numbers in the question and multiply them, we get an answer of 28. The last digit of this is 8, and so our answer must end in an 8. This means the only possible correct answer is A.